Hello everyone, let's find out what is the potential energy in an external field. There are two cases here where we find the potential energy of a single charge in an external field, and then the second case would be to find the potential energy of a system of two charges in an external field. Let's do the first one. We'll do the part 1. To understand this, let's consider an uniform electric field, a field which is something of this form. Now we know that we'll have a potential in the electric field, even though the field is uniform or maybe uniform, but the field will create or will have its own potential. Suppose here at a point A, at this point A, let the potential be V. We can connect E with V using the form E is equal to minus of dV by dr, or in terms of scalar value you can write this as E is equal to minus of dV by dr. By this form we can connect E with V. So let's assume that the potential at this point A is V. Now suppose if we bring a charge from infinity, think of a charge, say Q. This charge is being brought from infinity to this point. Now when we found out the electric potential energy for a system of two charges, when we brought the first charge, the work done then there was 0 because nothing was opposing its motion. But in this case, if we bring the charge Q, then the work done is not 0 in this case. Some work has been done here, and that work done is with against the field or with the field. Let's assume that the work is not against the field. So that work done is equal to, it will be Q into V, because by definition work done by a charge moved is called as V, or the work done is equal to Q into V, but the work done gets stored as potential energy. Therefore U is equal to Q into V. So to bring a charge from infinity to this point, the energy required is Q into V. That is for a single charge. Let's take a case where we have 2-point charges, or we need to assemble two charges. Again here, let's take a case where we have a system, the energy is uniform. Let's take 2 points in a system. Let the points be point A and then point B, and the separation between points A and point B, let it be some r. So distance between point A and point B is called as r. Now let's bring a charge Q1, or let the potential of the point A be V1, and here it is V2. Because it is an electric field, there will be some potential present. Let's assume that we bring a charge Q1 from infinity. So this charge Q1 is being brought from infinity to this point. It's being brought from infinity to this point. So let us call it as Q1. Now in this case, let us call the work done to bring that from infinity as W1, and this work done is equal to, W1 here means the work done to bring charge Q1 from infinity, that is equal to Q1 into V1 as seen in the previous discussion. Now suppose if you bring charge Q2, this charge Q2 is being brought from infinity again. We bring it from infinity to this point. Let's assume we brought it here to point B. Now there are two works done, so we'll call it as W2. the work is done against two forces now. One would be the Coulomb force, which is given by Q2 into E, because this may oppose the motion also. And also, in bringing the charge from infinity to this point, even Q1 will oppose the motion. So here two work is done. So we'll first write what is the work done to go against the electric field. That will be Q2 into V2 plus, look at this alone, the work done to assemble this alone, that would be K Q1 Q2 by R. So the only difference between the previous discussion when the field was 0 was, when the electric field was 0, these terms are not there at all. Because if there is no field, then there is no potential at all. But here, because of presence of the field, we'll have these two terms also. Therefore, the total work done to assemble the system would be sum of these two. Total work done is equal to W1 plus W2, that is equal to, it is Q1 V1 plus Q2 V2 plus K Q1 Q2 by R. But the work done is seen as its potential energy. Therefore, U is equal to this form. Recall that if you had only two separate charges, then these two terms were 0. But here it is not 0 because of an external electric field.